touch with you all for the past almost a month through the WhatsApp group, and almost at the end I have introduced our two eminent speakers, experts from the premier institutions of the world, Professor Basil Birinde and Professor P. Veeramani. Both of them are very close. Both of them have depth in the subject, fixed point theory and applications. If you Google, then also you can find. Professor Birinde, as I just now introduced, some partial introduction was given at the time. He is MS and BS and MS in computer science. Later on, completed his PhD in mathematics. And you can visualize his work, and you will find that a computer scientist is working as a mathematician. We have some interaction also. Yesterday, we three are interacting, and every day we three are interacting. Let me say our goal, what to achieve at the end of this workshop. Both will discuss fixed point theory and applications right from the initial concepts of fixed point theory. Few of you may know very well, or few of you may know little bit of it. As a student of this university or some other university, they have fixed point theory as one of the unit in the functional analysis. This I introduced here through the brewers meeting around 15 years back, sir, around 2009 or 10. Fixed point theory, this one, and advanced functions. So this time, because of the large number of faculty members in the department, so we have to curtail. That's why we have introduced one as a compulsory subject. So our motto is to introduce the fixed point theory. So basics I have sent you also. I have sent all the preliminaries, sir. You can, I think you have gone through also. It is in the given what the flavors are given at the time of inaugural. So all those things you need to know for the better understanding. While delivering the talk, your motive is also what the speaker wants to say, what is the philosophy of the speaker. It is always good to try to read the mind of the speaker. It is always good. And fly or swim along with his philosophy to how to construct a problem. That is only the motto for this, to invite such eminent people. And you know very well that in this fast world, staying in one place 5 continuous days is not so easy to anyone. And that too also, Bilaspur is almost 2.5 hours away from the airport. Even though professors did this in the interest of the students, research scholars and faculty members, okay, of this country, I say, because we have many participants from around the country. I am not specific to the state, but around the country. There are few people who are online also. We have given them the Zoom connection because of the attendance of such participants, like few participants still left in Nepal, Bahrain, Uttarakhand, and some of the other Punjab state. So every day end, before you go, you always have some sort of assignments. Those who are not willing to continue in a research as a fixed point theorist, but whatever the time you are given here, or paying the time, not just because of the student of this department or the student who has come over here to know what is the trends of the research. Deliberations, you can learn a lot. How the deliberations are given, what is the way to interact, how to interact the participants, what is the participatory contribution of any research. This is not a conference. We have already discussed yesterday along with Professor Veeramani and Professor Birende that, sir, this is not a conference. This is a workshop, and we start from the initial concept to up to that concept what the professors have done. Rather than saying professors, they are very good research students. You can learn them even at this age. They are very senior to me. Okay? So I should take this opportunity to thanks the director, the Mufti of IIT Hyderabad, who has given fundings to us by 8,000 USD for this 5 days GAN workshop. The national coordinator of GAN, Dr. Agrawal, IIT Hyderabad. Then the accounts department of IIT Hyderabad. Our local coordinator, Professor M.C. Rao of Guru Ghasidas Vishwavidyalaya, the management of our university, in particular our Honorable Vice Chancellor, Professor Alok Kumar Chakrawal, who has given lot of opportunities to every member of this university, always motivating. So thanks to him also, along with his better half, to thanks. He is also supposed to come, but due to some preoccupation could not come. So I once again welcome you all and just say a few things about Professor Birende, and then Professor Birende will start his lecture. As I said, he has published more than 200 research papers, okay, and particularly on iterative approximation of fixed points. And as I said, he has the top 2% mathematicians of the world. So you should feel proud that such a mathematician, and give a great claps to welcome Professor Pasile Birende. Okay, so I do invite. He has supervised 21 PhD students so far, right, Professor? 21 PhD students so far. And as I said, he is the reviewer, editorial board members of so many notified journals of the world, means world-class journals. So when the Professor Veeramani is come, I will speak about him also, what exactly the contribution of the Professor Veeramani. So Professor Birende, please.
Put somewhere to be free of holding it. Okay. Well, let's go to work now. My intention is to give you some ideas about what I did. It's not working well. Okay. So I would like to share some of my experience as a researcher, and as I promised during the opening ceremony, I would take any opportunity to show the human side of the research activity. Maybe you are here mainly for the mathematical content of this course. Once again, I want to congratulate Professor Murthy for obtaining approval for this course. I'm glad to be here, and I do hope you'll have the opportunity to learn something from my experience. So first of all, I would like to show you from where I come. This is Europe, and Romania, it's this country. Maybe you should come in front of the room. Please, there are many seats available. Just come and fill them to see, because this the screen is not so big, not so large, and you should see better. So come here. There are still 5-6 places free, even here. So this is the map of my country. We should know that the capital city is Bucharest. The main cities and the main universities are these ones. Main is now Cluj-Napoca, where I studied. I graduated here. Bucharest, Timișoara, once again, and Iași are the main universities in Romania. Baia Mare is here, just in the north. It's a medium, let's say average city with a medium university. So, as you could read in the material, my university joined, actually merged a technical university in Cluj-Napoca, and now we are a campus of this university in Baia Mare. A few words about Baia Mare. Baia Mare used to be a very important mining center, gold and silver producer, the most important in Romania, but now all mines are closed. It's a general policy of European Union to close mines and to take gold and silver from other countries. So in order to eliminate pollution, any chemical industry is polluting, and Baia Mare used to be one of the most polluted cities in Romania due to the chemical industry. Now it is very clean. It is a green city because we don't have any chemical industry now. So I want to introduce myself. Professor Murthy introduced me, but I would like to do from my point of view. So, as he mentioned, I graduated computer science. At that time, computer science and mathematics were slightly different, in the sense that 75 of the curricula was common. So just the last 2 years in the bachelor degree, were different. So the basic was mathematics, and computer science was a kind of a specialization in the last 2 years. So this happened when I was a computer science, I studied computer science. So I worked after graduating. In Romania at that time, the government offered a position to each graduate. This is not more valid. Now we changed our rule, so it's not more a communist government. The communist government offered full access to education to all people, jobs and houses, all needed. But the principle was all are equal. So but people are not equal. This was the wrong principle of this period. But anyway, at that time, when we graduated university, we got a position depending on your rank nationally. So first one took the first as they want the position. So I took a position in computer science. I worked there as a programmer. Then in 1990 I joined the University of Weimar as an assistant professor. I did my PhD and then I have been promoted to associate professor after 4 years, to full professor after other full years, and since then I am full professor at my university, which now is part of Technical University of Cluj-Napoca. My university and it is a small university. And one of my big achievements was to got founding of the doctoral school. This was not usual for a small university. So this was one of my main achievements to get approval, because this was approved by the committee of the Ministry of Education, and starting from 2005 I started this program, and as mentioned by Professor Murthy, 21 PhD students finished PhD under my supervision. Well, I want to tell you some of my academic activity, because for me, unfortunately, or maybe fortunately, research was not the only one activity. Mainly I was a teacher, so I still teach with great pleasure. The subject I teach differential equations, partial differential equations. I teach subject which is for computer science. It's graph theory algorithms, or graph theory, as you wish. So I also teach for master degree students a course that I like very much. You'll understand later why I teach a course which is called Mathematics for Gifted Students, teaching mathematics for gifted students. This is my favorite course for master degree students who will become teachers. So Romania, it's a very small country in comparison to India, very small, 73 times smaller, but we are producing a lot of mathematicians, or very good mathematicians. We are exporting each year many very gifted mathematicians after graduating high school or after graduating university, and we still keep some for our country, but we are good producers. And the secret is that for more than 130 years we have a tradition in identifying talents, gifted people, and try to attract them to mathematics. Now things change it a little, but we still do it. So this course I teach is for teachers of mathematics, secondary schools, high schools, how to motivate, to identify gifted students and to motivate them to follow a career in mathematics, because my belief is that if you are gifted, you'll do a good mathematics career and you'll be able to do research in mathematics. So I did a lot of work for administration. How many? We are in November, so in March I stepped down, so I did almost 30 years administration work. Lot of waste of time and energy for administration, chairman of mathematics and computer science department for 25 years and also dean of the faculty of sciences. And I was also involved as a founding director of the Doctoral School of Mathematics in this period. In 2012, we merged Technical University in Cluj-Napoca, so the doctoral school became larger. I also worked in what we call in my country work for the benefit of the academic community. This means editor, reviewer, organizer of conferences like Professor Murthy is doing now. I was involved for a quarter of century in the National Committee of the Maths competition in Romania. We cultivate the passion for mathematics from 11 years. So we organize a national-wide competition which is called Mathematics Olympiad, which selects the best peoples and we try to attract them to do mathematics. Fortunately, there are many. Unfortunately, from them, when graduating high school, not more than 10% go to mathematics because the world changed, so now they prefer other professions like medicine, engineering, and some others professions, some of them far away with mathematics. But anyway, I'm confident after a strong mathematics education, they will become very good doctors, very good engineers, and so on. So we are happy with this. So I was in this national committee for many years. I was also involved in the leading of the Romanian Mathematical Society, which is an old mathematical society. I was for many years, 2 terms, member in the Mathematics Committee of the Ministry of Education. I was the chair of this committee for a term, and now I keep the position of the coordinator of the committee for accreditation of university programs in mathematics, bachelor, master, and PhD, because we have accreditation of all these programs each 5 years, so it's a periodic function. And last, I did research. Unfortunately, I said I did not invest more than 10-15% of my time to research, but I did with great passion. In the last years, most of my activity was focused on editorial. With my grandchildren. So what it remains for mathematics, for research, is just a little, but I'm doing deeply and with great passion. And this is what I want to suggest you. In order to be successful, I believe, this is my belief, in order to be successful in mathematics, we should keep balance in our life. Balance between research activity, between personal activity. When my PhD students, girls, married, girls, they are coming, Professor, I am very sorry, but I got pregnant. I say, I'm very sorry, I have to interrupt the program because I'll give birth. I said, no, this is more important than any paper or any research, do this, and you'll continue after a break. And I insist on this, especially for girls. Girls, in my opinion, one girls matter as three men, three boys. So this is my appreciation. So my wife counts as three men. They are professors, they are mothers, they are also taking care of the house, and we men, we are not very useful, just for some few things. So research I did with great passion, and as it was possible, I produced some research which I'm proud of. So I have some research. I would like to show you some of them, as I promised. But first of all, I want to show my academic children. So in this year, 1991, after 1 year I joined the university, I founded this journal. Now it is a Q1 journal. I'm proud of it, Carpathian Journal of Mathematics. It's indexed by Web of Science, SESCI. And I spent a lot of time with editorial work, so it's not easy. I also funded this journal, which wanted to cover the starting research activity of young people. You can deduce it's creative, just to encourage young people to do research, not so important to be published in a highly ranked journal, but to publish the results of the activity. So this is the second consuming time activity of mine as an editor. If you want to know more about my activity, of course I forgot to tell you I organized many international conferences, summer schools, and so on. Here it's from such a conference, the picture on my web page. You can find some other facts. I did not update this web page for a long time because I'm really busy. I want to close this introduction by paying a tribute to my professor. He was my PhD supervisor. I am very grateful to him, and I do recommend you to consider gratefulness for your teachers. They are, how to say, like fathers for us, and I'm grateful to Professor Rus. He's 88, but he's still active. You can see he's born in this year. He founded the first research seminar in fixed and point theory this year, 1969. So this university, Babeș-Bolyai University, now, in my opinion, they have the best research group in fixed and point theory, 55 years old research group. Starting from this year when we celebrated 50 years of activity, the name was changed to nonlinear operators, differential equations, and applications to indicate that fixed and point theory has application in this area. And actually, fixed and point theory, I'll tell you if I have time enough, was born just from differential equation. So differential equation suggested to consider fixed and points tools. He is the founder of the Fixed and Point Theory Journal, a very well ranked journal. Okay, it is better.
Skip it.
Is it connected? Can you hear me? Okay. So he founded this journal in 1981 under this name, Seminar of Fixed and Point Theory. It was actually a journal, kind of proceedings of the seminar, of the research seminar. And he published this number of papers very impressive. He's still active. You can see he published in the last 10 years. He's 88. So starting from 78 to 88, he published these numbers of papers, very active, and he's still asking me, Vasile, let's do this. And I say, Professor, I'm very busy, no, we should do this article, this paper together. And now we are working on this, on such a paper. And he is very well cited. He produced 27 PhD students, and I'm proud to be his first PhD student who graduated in this year. I produced, this is from a mathematics genealogy project, if you know, where we register. And my professor did his PhD thesis in differential equations. And working on differential equation for his thesis, he identified the role of fixed point theory. And so he became the founder of fixed point theory in my country and one of the leading experts and founders in the world. Now it's time to go to our work. So my plan is to tell you some things about the fundamentals of fixed point theory. You are familiar, maybe all of you are familiar with the Banach fixed point theorem, which Banach stated in 1922. This is the original statement. He stated this famous fixed point theorem in 1922 in what we call now a Banach space, which is a complete norm linear space of vector space. Something wrong? So what happened actually? Picard in a series of papers starting in 1890 devoted to differential equations, he used what we call now Picard iteration, that is, for a map T we define this sequence, which is a sequence of successive approximations or Picard iteration. And what he did, in fact, he did the following. He transformed the differential equation and identified, in his case, the right hand side part of the equation was a function of two variables, but I write it as one variable. And his method was based on this fact. Applying the fundamental calculus theorem, he used this, and he realized that if the derivative is less than, let's say, alpha less than 1, then he can prove the convergence of the sequence associated to a differential equation. So this was done by Picard. And what was the explanation? That Banach converted this idea, this method, into a very general. The secret is that Fréchet, another French mathematician, introduced what we call now a metric space. So Banach took this new notion and had the idea, and he realized that this technique of Picard can be stated in a very general setting. setting in the what we call now a Banach space. And this is the extraordinary idea. Banach was a very, how to say, picturesque person. He did not study mathematics at all. When he graduated high school, he and one colleague of his, one classmate said, we know all mathematics. We don't need to study mathematics at the university. And one of them went to philology to study languages, and Banach went to engineering. He's an engineer. And his story is unbelievable. So he served in during the First World War, and he was sitting in park and discussing with a colleague, with a classmate, about Lebesgue integral. And one person was walking around their bench, and he heard about, you said Lebesgue integral? Are you mathematicians? And say we discussed, and this was Schauder, which is famous for his theorem. So Schauder discovered Banach and involved him, and Banach did his PhD in a non-conventional way because he was not a mathematician, and his thesis is this one. So his main result is in brilliant mind, and he used to study, to work, not at his office or at home. He used to work and do mathematics in the bar, in the coffee shops. This was the way he was doing mathematics. Extraordinary. Anyway, let's continue. Then Kaccioppoli realized that this Banach principle can be stated and proved in a complete metric space. What I know now, we know and use it in this way. But it's important to say that the original version of Banach is used in application, mainly in engineering. More than 90% of applications are in Banach spaces, not only in this. So here it's the original statement of Banach theorem. You can see the contraction condition. This is the coefficient. It is written in French. And he just proved what we call the existence and uniqueness of the fixed point, nothing about the approximation of fixed points. After Banach established his theorem, people tried to apply its fixed point theorem to the differential equations studied by Picard. And it was a disappointment because they realized they cannot prove the Picard's theorems using only this theorem, because it was difficult to apply. We know an ordinary differential equation is transformed into a Volterra integral equation, and it was not possible to work properly with this Volterra integral equation. So people said, this theorem is not useful. But another Polish mathematician, I forgot to this Bielecki, if I'm not wrong, in 1959, he has shown that if we are in a metric space XD,
we can construct a new metric, let's say rho. D is equivalent to rho, and under this new setting, the Volterra integral operator, it's a contraction in the usual sense of Banach. So this was the moment people said, oh, Banach theorem is really very important and useful. And you realize that since 1920 to 1962, because this was the moment some other theorem, there was no interest on this fixed point theorem. People said it's not useful, not interest. But after that moment of Bieletsky, and this distance is called Bieletsky norm or Bieletsky distance, he relaunched the interest for fixed point theory. And this can be considered the real moment the fixed point theory started to exist. And there is an Indian mathematician, Kannan, who did the first important contribution regarding this. He considered what we call now Kannan contraction condition. Instead of considering this contraction condition, he took these two distances. Took these two distances, and he has shown that the conclusion of Banach fixed point theorem holds even if we have this condition. And what is important, while T in which satisfies the Banach contraction condition is always continuous, a map T which satisfies the Kannan contractive condition is no more continuous. And this is a very important moment in the history of fixed point theory. There are many other important conditions I mentioned here. This nice combination of Banach and Kannan done the same year, you can see. Chirich 1971, Reich 1971, and Professor Ruz 1971, but the paper was published in 1972. So all these three mathematicians unified Banach and Kannan's fixed point theorems to get the same conclusion. This map, a map which satisfies this condition in a complete metric space, has a unique fixed point, and we can approximate this fixed point by Picard iteration. And of course, when B is 0, we get the Banach contraction condition. When A is 0, we get the Kannan contraction condition. As I know, Kannan, maybe I'm wrong, Kannan moved to United States, and he was working in computer science, I guess, rather than in mathematics. At least I know. Okay, at this moment I want to draw your attention to the following fact. Now, one person here present at the opening ceremony that in some sense fixed point theory is saturated. He is quite right in some respect. What does it mean? People are introducing a lot of so-called generalizations. So what does it mean, generalization? We start from a theorem, or from many theorems, in a certain setting or under some assumptions, and we obtain theorem 1a. And we pretend this is a generalization. So this is not a generalization. If we do not show concretely that we can give an example, at least an example, that this theorem works and this theorem do not work. So these three mathematicians, Ruz, Chirich, and Reich all did this. So Bruce presented this example. He has shown that this mapping T satisfies CRR, Chirich-Reich-Rus condition, but does not satisfy neither Banach, because T is not continuous, nor Canaan contractive condition, because we have this contradiction taking x1 over 2 and y1. So this is the way we should improve results in fixed point theory. A generalization which is not shown to be an effective generalization is not a generalization. And unfortunately, there are many such kind of results. I speak here as an editor. So as an editor, as a reviewer, I always ask authors to provide proof that their new results are really new, are effective improvements of the existing results. So the same did Reich. His example is also nice. The same has shown that I did not include the Chirich examples. Now, another Indian mathematician, India contributed to this field much at the beginning, and now there are many. I'm surprised how many people are interested in fixed point theory. Chatterjee published his paper, I'll show here, just to, sorry. He published in a journal, Bulgarian Academy of Sciences in this year, and he used a kind of dual condition in comparison to Canaan. And he did the same. He shown we have the same condition. I did not read here the author, is Zamfirescu, sorry. Zamfirescu is a Romanian mathematician. He was very young when he provided this nice theorem. I insist on this because it is the starting point of some of my contribution in fixed point theory. So you have seen, Chatterjee is with dx ty dy tx. Canaan is with dx tx dy ty, and Banach is with only dx y. So, sorry. Zamfirescu proposed this very nice theorem, and the statement is very easy. We have a complete metric space, we have a map T, and if for each pair of x and y, if at least one of the three conditions is satisfied, then T is a Picard operator. What does it mean, Picard? This notion has been introduced by my professor Rus, so means that this map has only one fixed point, and the sequence of successive approximation converges as n tends to infinity. This means Picard operator. Banach, it's a Picard operator, Canaan is a Picard operator, Chatterjee is a Picard operator, Zamfirescu mapping is also a Picard operator, in the sense we have unique fixed point and the sequence of successive approximation converges to this fixed point. So here it's a diagram. Zamfirescu in his paper, at the time, it was about 1999, I was teaching a course exactly fixed point theory. At that time, in Romania, the bachelor degree was 5 years. Now it's 3 years. So they shorten, and in the last year of study, so in the 5th year, we had some special courses, optional courses. So I taught this course, I enjoyed very much, and I came across with Zanfirescu fixed point theorem, and I was unable at that time. A break. You should understand how easy it is now to do research. You have access to a lot of information on the internet. At that time, at that time we already had some databases, but in 1980, in order to get a copy of a paper, we used to write a postal card to the author and please send me a reprint of your paper. This, for example, I sent to Australia. It took 1 month to get the answer. Now you can access the paper, or at least some review on that paper immediately on the internet. So at that time I was not able to get a copy of this paper because in Romania this journal was not in the libraries. Any mathematical library did not have this journal in their collection. So I tried to prove this theorem, and first of all the idea was that Banach condition, Canaan condition are independent, and also Chatterjee contractive condition is not put here, are independent. Here is just the Chirich-Rice rules, which unifies the conditions Canaan and Banach. And Chatterjee will come something here. I knew I draw it, but it is not here. So during this, teaching this course, no, not yet, I tried to prove myself this theorem. And I did several trials. I do this in front of my students, and I am not ashamed if I do not succeed to prove something. Some of them, Prof, could you prove this? Let's try. And for this theorem, I really told my students, I don't know how to prove this theorem. Let's try together. And during the tutorial, we did some steps, and we were not successful to prove Zanfirescu fixed point theorem, because it was unusual. So for each pair, so we are on Banach condition. For other pair x, y, we are on Canaan condition. For another pair x, y, we are to Chatterjee. So any kind of combination, how to master this, how to deal with them, and in the end, I succeeded, and this was the moment I discovered a new class of really impressive mappings. But first, I want to close this section by telling that there are many contractive conditions. This American mathematician in 1977 did classifications of this condition which arise from Banach contraction condition, and there are mainly 25 conditions, main. Banach is the first, Canaan is fourth, and so on. And all these, almost all, these conditions are stating their conclusion is that if we have a mapping in a complete metric space and it satisfies such a condition, then T is a Picard operator. This means we have unique fixed point and the Picard iteration converges to this fixed point. But this theorem shows that from a theoretical point of view, these many theorems are actually equivalent to Banach fixed point principle. Why? Because look, there are only two parts, two items in this theorem in the book of Professor Roos, and Petrushel Adrian is his second PhD student, and Petrushel Gabriela is the wife of Adrian Petrushel. They wrote this very important monograph in fixed point theory. If some of you want a copy of this book, I can provide you the file, the PDF of this. Is very useful for those who are interested.
I have a hard copy of this. I used to provide.
Okay, I can provide the soft copy of this and to spread to all of you.
Yeah, please send it.
Because when you work in this area, this should be the Bible. So you should read and see what was done, okay, until 2008, because this was the moment the book has been finished. And in this theorem, what is the idea? If we have a non-empty set X, we have a map T, self-map, then these two statements are equivalent. If there is a metric D on X, such that this map T is a Picard operator, in this sense, I have written here, this is equivalent to the fact that we can find the constant alpha, we can find metric, complete metric, I forgot to put here D, on X, such that this map is in fact a Banach contraction. Well, from a theoretical point of view, what does it mean? That tens, hundreds of fixed point theorems which have this conclusion, T is a Picard operator, are equivalent to the Banach contraction principle. But this is in theory. In practice, it's not easy to find this metric, to construct this metric. So these theorems are important. So Canon we can apply to some kind of problems. Chatterjee to some kind of problems. Recently, I attended a workshop in Belgrade, in Serbia, and there is a lady, Maria Cvetkovic. She is working in fixed point theory, and she's interested to construct such equivalent, such metrics. So we have a Picard operator, and to try, and she did for Canon. She did for Canon, she obtained a metric, and under this metric, the Canon theorem is equivalent to the Banach fixed point theorem. But these theorems are nice, and one of the nicest theorem here is the Chirich fixed point theorem I mentioned here. Chirich is this mathematician. They pronounce Chirich. I went in Belgrade to give homage to Chirich. I did not meet him in person, but we have some correspondence, and he was a very great mathematician. He is, by the way, founder of fixed point theory in Yugoslavia, former Yugoslavia, in Serbia. And his condition is this one. Is the most general. So it includes all these distances. dy, ty, dx, ty, and dy, dx. Very nice condition, and the most general in this class of conditions